Let's take a look at number 12 in section 4.2 of Achieve. Here, we're defining the minimum and maximum for this function on this closed interval from 1 to 6. So you should have some polynomial function similar to this in your problem. And they give you directions specifically how they want you to do that. And this is important. On the test, you have to show support. And what I'm showing you is the way to show that support. It has to be very clear. Many of you know how to use your calculators to find max and mins on closed intervals. That is not going to cut it for explanation or support. You can certainly check that way, that's fine. But you should show the following work. So first of all, you need to find the critical points, because what we're going to do is we're going to check the value of this function at these endpoints, which are 1 and 6 on this closed interval, and any critical points on that closed interval. Because why? The extreme value theorem states and can be proved, right, that any continuous function on a closed interval is guaranteed to have a maximum and minimum. What we know further is that max or min has to occur either at the endpoints or at a critical point. Okay, so here's a closed interval. This function is clearly continuous. Derivative is needed for the critical points. Very easy to find, right? Derivative 4x cubed is 12x squared. Derivative negative 24x squared is negative 48x. Derivative 17 is 0. I'd like to factor this. So it helped me find my critical points. I factor out a 12x, the GCF, leaving x minus 4. And so either x being 0 here or 4 will make the derivative 0. The derivative is never undefined. It's a polynomial function. And so those are our critical points. Now, when we go to check, I said check critical points, but notice it's on this interval from 1 to 6. Notice 0 is not in this interval. You're not going to use 0 to help you determine the max or min on the interval from 1 to 6, right? 4 is between 1 and 6, but not 0. So first step, show clearly the derivative and the critical points, and then show a table of values like this, right? Endpoints 1 and 6, and the only critical point on that interval is 4, so don't include 0. And then we simply evaluate the function at 1, 6, and 4. So I showed it plugged in here. You can use your calculator to do this part. I would like exact values here. So if the exact value is, say, the square root of 3, you should write that, as opposed to 1.7 something. If the exact value is pi divided by 2, that's what you should list. Whatever the exact value is, you can then approximate. Pi divided by 2, you can say is approximately 1.57. So you can check that way, but give me the exact value. Now, what's the max and min? Well, we're guaranteed that the max and min has to occur at one of these three numbers. Well, what's the biggest number? 17. So there's our max. What's the smallest number? Negative 111. So there's our min. So the maximum value is 17. The minimum is negative 111. They have the max written as y with a subscript max. So the maximum value. And this is the way they write the minimum value, and you plug those values in for the answer. But again, getting the answer is one thing. Showing support, very important that you know how to do this on the test. This is what I'm going to be looking for. Okay, hope this helps with this.